Hello guys, welcome back to my channel. So for today's video we will talk about the properties of exponents. And before we get into the 8 properties that I prepared for you, let's first define or get to know what is exponents. So an exponent, or also called power or degree, tells us how many times the base will be multiplied by itself. For example, the exponent is 5 and the base is x. This means that the variable will be multiplied by itself 5 times. You can also think of this as to the 5th power. So exponent is just how many times you multiply your base. So for exponent, or for x raised to 5, so here your x is the base, your 5 is exponent. You may read this one as x raised to 5, or x raised to the power of 5, or x to the 5th power. So by definition, this means that you are to multiply your base, which is this time is x, 5 times. So you can write it this way. Okay, 5 times. So that what it means to have x raised to the 5th power. Now let's go to the properties of exponents. Again, I prepared 8 properties for you, and expect that on our next videos, I'll be talking about each property and give you several examples para mas maintindihan po ninyo ang each property. So let's have first number 1 property is what we call the product rule. Here we have the properties on this column. We have the general form on this column, we have the application in this column, and I prepared one example for each column. Again, there will be series of videos wherein I will talk about each properties and give you several examples. So number 1, we have product rule. Means same base, you have to add the exponents. So this is your base. So general form of the product rule is a raised to m times a raised to n. So it says that you have the same base, where in this case you have base a. Okay, if you have same base, then what will happen to their exponents is that you will just add their exponents. So the application will be this one, a raised to the power of m plus n. And we have here one example wherein here you have x as your base, the other x is raised to 5, and the other x is raised to 3, and therefore they have the same base. We have to add their exponents, and it will give us an answer of x raised to 8, or x to the 8th power. Now number 2, we have what we call quotient rule. So for quotient rule, still you have to have a same base. Then if you have the same base, subtract the exponents. So this is the general form. You have a as the base for both numerator and denominator. You have m as the exponent for the numerator, and n as the exponent of your denominator. So you have the same base. You can rewrite it this way. So this is the application part. So as you can see, the exponent on the numerator will be subtracted by the exponent on the denominator. Okay, making it, for this example, x raised to 9 over x raised to the 5th power will be equal to, of course, according to the application and the general form, we are to deduct or subtract 9 from 5. So 9 minus 5, that will be equal to x raised to the 4th power. Next, the third property is the power rule 1. In this case, to raise a power to another power, you have to write the base and multiply the exponents. So if you encounter this form, an example of this form, a raised to m, parenthesis, open and close parenthesis, raised to the nth power. So as the rule says that to raise a power to another power, write the base. So we have to write the base and multiply the exponents. Okay, so we have here an example of x raised to the 3rd power raised to 4. So we have to multiply 4 and 3. That makes here 3 times 4. So your final answer is x raised to the 12th power. Number 4, expanded power rule. So an expanded power rule, it says the product to power, okay, distribute to each base. product to power, distribute to each base. It means in this case you have a different base. However, it is raised, or the exponent is the same. You have here m. So you have only one exponent for both a and b, and therefore you are to distribute. You may distribute your exponent to each base. Okay, so you have a raised to m and b raised to m. Example, you have 4x to the third power. You have this one, this is 4 is your a, x raised to the third power is your b, and what you have to do is just to distribute your exponent, which is this, in this case is 2, and therefore you have 4 raised to the second power, or 4 raised to 2. Then this one, the b part, this part, you can apply the power rule number 1, wherein you are to multiply the exponent. So it becomes 4 raised to 3 times 2, and therefore this one is 6, this one, and 4 raised to 2 is 16, and therefore your final answer is 16 raised to the 16x raised to the 6th power. Okay, next we have number 5, negative exponent. You have to flip and change sign to positive. So this is the general form. If you encounter base a raised to a negative exponent or a negative power, what you have to do is just to flip and change the sign. So this is the application. You may write this one to this one so that the sign of the exponent will become positive. So for example, you have x raised to the negative 3. That is equal now to 1 over x to the third power, or x raised to 3. Number 6, negative exponent. Okay, flip and change sign to positive. So in this case, so as you can see above, it's a raised to the negative m, negative power. In this case, it's 1 over raised to the negative m. So what you have to do is to bring this 1 here on the numerator. That makes it 1 over m. So if you will bring this 1 on the numerator, then the sign becomes positive. Okay, and example is this, 1 over x raised to the negative 5. If we will bring x to the negative 5 above, it will become x to the 5th power. Number 7, 0 exponent. So any base except 0 raised to the 0 power is equal to 1. So this is the general form. It means any number, okay, any number raised to 0 is equal to 1. Kahit na malaki, gaano man kalaki, 1 million man to, basta if you will raise that to 0, and the answer is always equal to 1. Like this example, the quantity of negative 4x raised to 0, that's always equal to 1. Okay, by the way, it says here any base except 0, because 0 raised to 0, it's undefined, or your calculator will give you math error. By the way, a here is a variable. It means it could be any number or any other variable. It may be 2 terms, 3 terms. Okay? Fractional exponents. So for fractional exponents, we write the power in numerator and the index of the root in the denominator. So for fractional power, it is like this. It means you have a as the base, and then we have a power or an exponent wherein it's a fraction, m over n. So you may write that one as square root of a raised to m, and you have to put n as the index of the root. Okay, so your denominator here will be the index of the root, then you have your numerator m will be the power of your base. Okay, let's have this example. We have 4 x and raised to, you have 5 over 3, say 1. So you may write that one as the cube root of 4x raised to 5. Okay. So these are the 8 properties of exponent. Again, on our next videos, we will talk about each of these exponent properties. We'll talk about this one by one, and I will give you several examples for you to understand fully what are these properties. And these properties of exponents are actually very important in your subject in mathematics. So, thank you so much for watching. So don't forget to subscribe, like, and hit the notification bell. Thank you so much, and God bless.